Okay, good morning scholars, welcome to another science lesson. Today we're going to be looking at how we use different energy resources to generate electricity. If you haven't completed the do now, please pause the video and then come back in a few seconds once it's done. Okay, so question 1, what is the equation for efficiency in terms of energy? So its efficiency is useful energy out over total energy in. What form of energy do you put into a motor? So just like we spoke about yesterday, that's going to be electrical energy. What is the electrical energy transferred by a 6-volt motor with a current of 3 amps that runs for 5 minutes? So this is where they're trying to catch us out here. That's 5 minutes, not 5 seconds. So I need to convert that to minutes by timesing it by 60. So that is 300 seconds. We'll use E equals IVT, just like we did yesterday. And that gives us 3 times 6 times 300. 5,400 joules. What is the equation for the energy stored in a spring? So that is elastic energy, big A with a little e next to it, is 0.5 times the spring constant K times the change in length, the extension, squared. So 0.5 KE squared. What is the power of a lamp with a PD of 5 volts, potential difference of 5 volts and a current of 2? So power equals current times potential difference is 2 times 5 equals 10 watts, and it's a capital W. Okay, so we've got quite a dense DI today, so I'm going to talk through this a little bit, but I'm not going to read it out word by word because you're able to pause the video, read through it and have a look. We'll fill in the table first. There's a few gaps that I've left on purpose, but before we can do that, we need to know that we have this idea of renewable energy, so we can generate electricity using all of these different sources. If we can replenish it, or one that's being constantly replenished, we can call it renewable. If it's going to run out, so for example coal is not renewable, so it is non-renewable, that's going to run out one day. It's going to run out quite soon, and it's not being replenished, it's not being replaced as we use it. Gas, again, this is non-renewable. Oil is non-renewable. So these three here are all examples of fossil fuels. So these were formed millions of years ago when organisms died and were covered in sediment, or they sank to the bottom of the sea and were basically somewhere where the air or the oxygen couldn't get to them, so they didn't break down properly. Then over millions of years they formed these fossil fuels. Good thing about these fossil fuels is when we burn them, it gives us a lot of energy. So the energy density is very high, the power output is very high. Main impact is that when we burn them, it releases carbon dioxide, and this is massive. The release of carbon dioxide leads to the greenhouse effect, which is the cause for global warming. So if something gives out CO2, then it contributes to global warming, which is it makes the earth hotter. It's the global increase of the average temperature. It's only happening by 1 or 2 degrees, but it's got a huge impact. The next one here, we've got nuclear, so we use uranium. If we put enough uranium together, it gets very hot and it releases lots and lots of energy. So one good point about nuclear energy is it's really, really high energy density. It is, however, non-renewable. We've got about 160 years worth of uranium left if we keep on using as we are doing. Problems are it gives off it's what's left over is radioactive, so it's really, really difficult to dispose of. One good thing is, though, it doesn't give out carbon dioxide. So if we were to use nuclear rather than these three, that would be good because it has less of an impact on global warming. Biofuels, so when we're looking at biofuels, this is the idea of growing plants and then fermenting them, and then we can burn them as a fuel. This is good because it's renewable. So yes, we're renewable, and also it's what's called carbon neutral. So when we grow the plants, they take the carbon dioxide out of the atmosphere. When we burn the plants, it puts it back in. So we're not really increasing the amount of CO2 in the atmosphere. Wind, so you've got big turbines that spin round and they generate electricity in the wind. That is renewable. Problems are it doesn't give you very much energy, and you need to build lots of them, so it's a bit of an eyesore, so you have your environmental impacts here. Hydroelectricity is also renewable, so you basically build a big dam that stores water at a high point, and then as the water drops down through a pipe, you can use it to turn turbines and generate electricity. Geothermal is also renewable. That uses the heat from deep down in the Earth's crust closer to the mantle to boil water, turn it into steam drive turbines. So it's only really useful where there's lots of where you've got lots of geothermal activity. So places like Iceland and Greenland are good. Places like the UK, not so good. So medium energy output but very low environmental impact, so it's quite a good one. Tidal, so obviously I don't know if you've spent much time looking at the sea, but twice a day the tide goes out and comes back in every 6 hours or so, and that is due to the moon. It is renewable because the moon's always going to be there, and the tides are always going to be going backwards and forwards. You can get a lot of energy out of it because you've got a lot of water moving, but it's difficult to harness. Solar, so we can use solar panels to convert the sun's light energy into electrical energy. Sun's always going to shine as far as we're concerned, so yes, that's renewable. And problems are you can only use it in the daytime. If you use it in the UK, it's a bit cloudy, so it's probably not going to be very good. Waves, so the fact that the water waves move up and down, we can harvest that energy. It's renewable. It's renewable, but you don't get very much energy out of it, but it doesn't impact the environment very much. So most of today's lesson is going to be about evaluating these resources. So every time you have to answer a question like this, you want to look at the source that you're analysing. So for example, nuclear, I would say, is it renewable or non-renewable? Well, it's non-renewable. The power output is very high. Whether the infrastructure is already in place, well, we've already got quite a few power stations, so yeah, that's already in place. Does not release CO2. The problems are that it doesn't impact global warming, but the environmental impact is that it has radioactive waste that needs to be disposed of safely. And then anything else relevant, we might run out of it one day. So any extra things that you know can go in this point. So every time you're asking these questions, work through these 1, 2, 3, 4, 5, 6, 7 points. When you're going through the questions later on in this packet, flip back to this page or go back to this point in the direct instruction to have a look at it, but always go through these. So your first job is to have a look at these images. What form of energy do you think they represent? For example, this one up here, I believe it is oil, and I think that because there are loads of oil drums lying around and there is an oil rig in the background. It also asks me to identify, also to give the environmental impact. So let's flick back up to here. Oil releases carbon dioxide. And that's all we have to do. So have a go at these, please, and let me know how you get on. So this next question is quite difficult when you first look at it, because all you get given is a graph, and you have the question. The graph gives information about the production of electricity in 2016, something about a climate agreement, not really relevant, and then it commits the UK to reduce the amount of CO2 released into the atmosphere. Then explain which resources you should use in the UK to get rid of carbon dioxide, basically. So if we look at these, we have gas, and we have coal. These are both fossil fuels, and they both give out CO2. So we can't use these, right? If it's giving out CO2, we're not going to be able to meet our Paris climate agreement, which is reducing carbon dioxide. So we're going to ignore those, and we're just going to focus on evaluating nuclear energy and wind energy. This is how we do it. Again, I've put up my 7 points. I've stated that nuclear is non-renewable. You've got a high energy density or output. You've got power stations that are already built, so that's talking about infrastructure. There is no carbon dioxide released, so it doesn't impact on global warming. However, the environmental impact is that it produces radioactive waste, and any relevant information, well, it's very reliable. So you know exactly how much power you're going to get. It doesn't really matter if it's windy or what. Then we'll have a look at wind, and we need to evaluate the wind. So it's renewable, very low energy output, so that's not good. Few wind farms are already built, so that's not very much infrastructure in place. No carbon dioxide is released. It doesn't impact global warming. It takes up large areas that can be used for farmers, so it's got quite a big impact on the environment, but it doesn't have any fuel costs. So all I've done is gone through those 7 points from the direct instruction here, and I've matched it to what we can use. If I'd have done this would have got me 6 marks out of 6. So if you have to evaluate them, make sure you get all of these points for each energy resource. Okay, so your first task, or your first main task really, is to evaluate nuclear power compared with shale gas. So shale gas isn't something that is on the specification, so we don't need to know any information that isn't in the question. We know it's gas that's trapped in rocks, so it's extracted by fracking. That doesn't sound good. It causes earthquakes, and it adds CO2 to the atmosphere. So we need to say that shale gas isn't good because it does these things, whereas nuclear power is good because of these reasons here. So use what we've spoken about before to structure your response. Okay, the last independent practice task is just an evaluation of these 3 methods. So we have coal at the moment, we have tidal, and we have wind. So all I would like you to do is give me the 7 points for each of these 3 things, and then I want you to evaluate it. So an evaluation is an offering of your opinion. So which one do you think is best, and give me 1 reason.